Okay, now here's the final standard everybody takes during the final period, in addition to any standards that you have not locked by the time the finals period comes around. Okay, but everybody takes this. And you have two sides of your sheet. You have all the perfect square numbers and their square roots, what they equal, and then the SOHCAHTOA, the sine, cosine, tangent thing. Okay, now your job here is to simplify the expression, and newsflash, punching it into your calculator is not simplifying the expression. You should not hit that square root button once when doing this standard, okay? Not once, okay? Because you have everything you need right here. So the square root of 16, look at your thing. Well, 16 is actually on here, so it has an equal right away, and it's equal to 4. Okay, now 98's not on here, so what I need to do is start trying to divide 98 by these numbers in the square roots. So 98's between 100 and 81, so I'd start dividing at 81. 98 divided by 81. Okay, that didn't work. Now divide it by 64. 98 divided by 64. That did not work. Now 98 divided by 49. Cha-ching, okay? So now that I got something to work, I make two square roots. And I put the number that I divided by first. You got to put it in the right order. You're never going to get it right. Okay, you need to put 49 first, and then the answer second. Now, the square root of 49 has an equal, and it's 7. So I replace this with just the number 7. And then my answer is 7 with a square root of 2 next to it. Okay. Next one, square root of 21. Now 21's not on the list. Okay. It's falls in between these two. So I'd take 21 divided by 16. That's a decimal. 21 divided by 9, decimal. And then 21 divided by 4 is another decimal. So if I can't divide by anything here, and not come up with a decimal, then I circle this as my answer, okay? It's what's called a prime square root, meaning you cannot divide it by any of these things. It's prime, okay? Okay, now moving right along to the next thing. Okay, simplify. Once again, you should not, when doing this standard, you should not go second this one time, okay? Not once. Okay, so we got the square root of 18, but then it's got variables in it, x to the second and y to the x to the sixth and y to the ninth. So what I'm going to do is break this up so that 18 gets its own square root, the x to the sixth power gets its own square root, and the y to the ninth power gets its own square root. Okay. Okay, so 18. 18 is not on in one of the numbers that are perfect squares, so I'm going to start in this range because I divide it by 16. Okay, that didn't work. Now divide it by 9. You just go up the column. 18 divided by 9. Okay, that worked. So I make two square roots out of it, and I put the 9 first and the 2 second. Okay, so the square root of 9 is equal to 3, so this needs to be replaced with the number 3. Okay, it's 3. That's, I can't see it, I can't write. Okay, so 3 square root 2. Now, when doing variables and exponents, you want to write x times, that's what x to the 6 means. It's just a product of 6 x's. Now, with a square root, we want to circle 2 of them at a time. So 2 at a time. 1, there's 2 circles, there's 3. Okay? So how many circles was I able to make? 3. So it's x to the third, not 3x. X to the third, and there are no x's left without a partner, so it's just x to the third. Okay, now y to the ninth. Okay? It's a product of 9 y's, okay? I know it's kind of a pain writing 9 y's. Don't be lazy, just do it. Okay, so I circled 2 at a time. So there's 1, 2, 3, and 4 with 1 left over, so I put a square root around the leftover. So how many circles did I make? 1, 2, 3, 4. So it's y to the 4th power, but then we have this y left over in a square root. Okay, so now after that's all done, I'm going to circle the three things I came up with, this, and I make a square root. So I put a 3 outside and a 2 inside. I put an x to the 3rd outside because I don't have a square root there, so it automatically goes outside. And then I'll put a y to the 4th outside, and there's going to be a y inside. Okay, so that's how you do that. Now, we have a multiplication problem and an addition problem. They are totally different procedures. The multiplication is 3 steps, so 1, 2, and 3. Okay, anytime you see multiplying with square roots, you need 1, 2, 3. So what I do is I take the 3 times the 2, that's 6. And then I make a square root and I take 20 times 2, and that's 40. You multiply the outsides of the square root and the insides. Now the second step is taking 40 and seeing first off if it's actually on the list, which it is not. Okay, 40 is nowhere to be found. And then I see if 40 can divide by one of these numbers up the column here. Okay, so 40 divided by 36. Didn't work. 40 divided by 25. Didn't work. That's 1.6. 40 divided by 16. Okay, that's 2.5. That's not going to work. No decimals. 40 divided by 9. Doesn't work. And then 40 divided by 4. Okay, I got something. Okay, so I put my calculator down here, and I drop the 6, and then I write times square root, and I'm going to put 4 first, and then 10. So 4 and 10. So the square root of 4 has an equal, and it's equal to 2, because 2 times itself is 4. So you get rid of this, and that's 2. And then I need to multiply the 6 and the 2 together, and that's 12. And then I just put the square root of 10 right next to the 12, and that's the answer. Okay, now adding, okay? Adding is totally different than multiplying. It is not the 1, 2, 3. I don't want to see that on addition. You can't add anything right now because the numbers under the square roots are totally different. We need to come over here and make a little graphic organizer and try to get the numbers under the square root to be identical. So I have 2 square root 12 and 3 square root 27. Okay, now what I do is I take the square root of 12 and try to simplify that. Well, is 12 on the list? No, it's between these two, so I divide 12 by 9. That didn't work. And then I'm going to divide 12 by 4. Okay, that did work. Okay, so what I do is I drop the 2 and then write a product of 2 square roots, just times square root, and I put 4 and 3. Now, this always has an equal. The 4 does whatever number's there, and it's equal to 2. So what I do is take 2 times 2, and that is 4 with the square root of 3 connected. Okay, now right here, 27. Now, is that on the list? Nope. Okay, so 27 is between these two. So I'd start dividing 27 by 25. I got a decimal. Now try 16. Decimal. Now try 9. Okay, I got something. So I got these. Now this outside 3 just drops down times square root times square root. So I divided by 9, and I got 3. Now this always has an equal, and its equal is 3. So now I multiply these two 3's together since neither one is in a square root anymore, okay? Because I eliminated the square root, it became 3. So 3 times 3 is 9. Okay, now look at these two, and what is the same? What's the same? The square root of 3. And now I add 4 and 9. It's like 4 square roots of 3 plus 9 square roots of 3 would be 13 square roots of 3. It's like adding x's, same concept. Okay, there's plenty more of these coming at you. Okay, now I'm going to flip over to this because you got 2 more and they involve the SOHCAHTOA and the trig ratios. Okay, trig geometry. Okay, so find the 3 trig ratios of the angle theta, and you see sine theta, cosine theta, tangent theta. So it's the 3 lines. And now I go label the sides because I know the sine is O over H. The cosine is A over H, and the tangent is O over A. Okay. All right, so then I need to know what side's what. So this is my hypotenuse, okay, across from the right angle. I know that that's 20. Okay, now here's my theta sine, and I use that to find my opposite. So across from that's the opposite. And I don't have a number there. I'm going to have to eventually find that. And then the third side of the triangle is your adjacent side. So to find your third side, when you know 2 of the sides, you use the Pythagorean theorem. But it's not a squared plus b squared equals c squared. It's going to be a to the second plus o to the second equals h to the second. So a I know is 8. O, I don't know that. That's x to the second. And h I see is 20. That's 20 to the second. Okay. Now I need to find what those numbers to the second power are. You can either take 8 times 8 or 8 to the power of 2. 64 plus x to the second, and then 20 to the second. That's 400. Okay, now we got to get the x by itself, so I subtract 64 from both sides. I take 400 minus 64. I got 336. So now since it's to the second power, I need to find the square root of 336, and now I can just use my calculator, okay? Okay, 18.33. I don't care. I'm not going to write positive, negative, because not when I'm doing a triangle. So this O I don't know. I know that's 18.33. Okay, so now let's just replace these. So O is 18.33. H is 20. A is 8, and H is 20. You don't need to reduce it. It's fine. 8 over 20. Okay, O, so O is 18.33, and A is 8, okay, and that's my answers, okay. Okay, now for the last one. Find the 3 trig ratios of theta. Okay, no, sorry, this is sorry, these directions are wrong. You need to find the 3 sides and the 3 angles. Okay, find the 3 sides and angles. I misstated the directions. So you see down here, you need to find all 3 sides, and you need to know all the angles. The angles are really easy, okay, if you have a clue. Okay, so here are my sides, so I need to know which side's which. So across from that is my H. I have no number out there. There are no units out there, so I don't know H. Now, there's no theta sign, but if you look inside the triangle, you have 37 degrees, okay? So across from that is O, and then you need to write 37 degrees right there. That's known as your reference angle. Okay, and then the third side is A, and that A actually has a 12 units with it, so I'm going to go put 12 here. Now, I don't know these two sides, okay? I don't know how long the H is. I don't know how many units long the O is, okay? So these are the two I don't know, so I need to keep those separate. Okay, and I'm going to pair that with both of them with the side I do know. So O and A, and H and A. Okay, so then we set up these ratios, line equals line. Okay. So if you're doing O and A, which one would that be? Well, it wouldn't be sine. It wouldn't be cosine. Oh, it'd be tangent. So I write tan. But in parentheses, instead of putting theta, I need to put 37. And I always put a 1 under it. And tangent is O over A. Okay, and O I don't know, so that's going to be X. And A I know is 12. Okay. So now here's the X. So I need to multiply the other way. I'm going to circle this because I'm multiplying tan, parentheses 37 times 12. And then I'm going to divide by 1. It's just cross multiply and divide, but you want to write it out so you don't punch it in wrong. So tan 37 times 12 divided by 1. And I got 9.04, and that's the O. Okay, now H and A, which one would you use? Well, it wouldn't be sine. H and A would be cosine, so it's cos. And then you need to put your reference degrees in there, over 1. And then, I don't care, it's not H over A. Look at this paper, it's A over H. So A, H. So A we know is 12. And H I don't know, so that's X, okay? So here's the X, so I multiply the other diagonal. I take 1 times 12 divided by cos parentheses 37. So 1 times 12 divided by cos, hit that button, 37. Okay, I got 15.02 or 15.03. And that's your third side. Now you know how many units all the sides are. They're units. Like inches, feet, all those are units. Angles, you've got 90. Okay, you also have 37 degrees. And then to find your last angle, you just take 180 minus 90 minus 37. Really pretty simple. Okay, I got 53, so that final angle is 53 degrees. Okay, so it's only 8 problems, but you got to know your stuff, and you're going to review that pretty much every day coming up, unless you have other standards to lock.